Hello. Um, let's do a problem, shall we? I got a question about this birthday problem, and I thought it'd be easier to explain it in the context of a video. So we want to know the probability that at least two people in a room of 9 people share the same birthday. And we're going to ignore leap years and assume each birthday is equally likely. So we're going to say 365 days equals 1 year. No leap years or any of this nonsense. And I keep unplugging my computer, so bear with me for a moment. Oh, wrong way. Okay, I'm back. So, we want to find the probability that 9 people have different birthdays. So let's think about this. Just think about 9 people. The probability that the first person has a birthday on any given day is, well, it could be on any day of the year. And now I know what you're thinking, that equals 1. And it does. But now, let's use this and see if we can find a pattern. Second person has a, or actually here, let me say it this way. Now that we know the probability that the first person has a birthday on any given day is 365 out of 365, now we will know the probability of 2 different birthdays. And this is going to be, well, 365 over 365. That's for the first person we consider. Then the second person, if this person's going to have a different birthday, there's one less day to choose from. It can't be the same day as this person. And so this would be, of course, divided by 365 squared. 365 times 364. Now I want you to notice that this is 365 factorial divided by 365 minus 2 all factorial, and then divide by 365 to the second. And I know what you're thinking, why would I type it that way when I could just do this? Well, it ends up being much easier to solve this problem if you're able to see the factorial pattern. And notice that you get 365 factorial over 363 factorial divided by 365 all squared. And that leaves you with 365 times 364 divided by 365 squared. So you don't have to look at it that way, but I think it makes things a little easier. So remember that the probability that 2 different birthdays equals 365 over 365 times 364 over 365, which is 365 times 364 over 365 squared. And we can extend this pattern. And I want you to stop the video and see if you can figure out what it would be. You don't have to do the computation, just write down. It should look a lot like this. Okay, I'm hoping that you wrote something like this. 365 over 365 times 364 over 365, 363 over 365, which is, of course, 365 factorial over 365 minus 3 factorial. And then I'll just write this 365 to the third as a division. And again, you can see that this is 365 factorial over 362 factorial divided by 365 to the third. And that gives you 365 times 364 times 363, because everything from 362 all the way down to 1 is eliminated by the 362 factorial. And now we can rewrite this as 365 to the third. So see if you can guess what the probability of 9 different birthdays is by extending this pattern. Okay, I hope you stopped the video to figure that out. The probability of 9 different birthdays. I want to know what the probability of being in the world's loudest library is on this day. Apparently very good. So this is 365 factorial. 365 minus 9 factorial divided by 365 to the 9th power. And that is 365 factorial over 356 factorial divided by 365 to the 9th power. And I'm going to use Wolfram Alpha to compute this. You can use your scientific calculator or whatever you like. So this was 9. So 0.9054. And 4 decimal places, 9054. Good job. Yay for me. Now think about this for a moment. What's the probability that at least 2 people share a birthday? Well, this is going to be 1 minus 0.9054, which of course is 1 minus 0.9054, 0.0946. 0.0946. So there it is. I hope that was helpful.